So in order to graph this one, first remember what the parent function is. The parent function would be what would happen if we took out all the transformations. Well, that 3, that's a transformation. The 5, it's a transformation. My parent function here is just y equals 1 over x. So I know this general shape of this graph is going to be the same as it was for the 1 over x graph that we saw first yesterday, as well as on last night's assignment. But then we do need to consider what are the transformations being applied here. So first of all, what is the minus 3 doing to the graph?
Shifting it right.
Yep, it's in with x, so it's going sideways. Specifically, minus 3 goes right 3. Yes. And what does plus 5 do? The plus 5, since it's hanging on the end, yes, it goes up and down, and plus goes up. So that is shifting it up 5. Now, I know what the parent function is, and I know what the transformations are. I should now be able to graph it. But of course, this does have some other information in it, the asymptotes. So notice that our asymptotes, they move as well. So my vertical asymptote. Well, first of all, if it's going to be a vertical asymptote, so it's going straight up and down, is that an x equals or a y equals?
Oh,
that is x equals, yes. So in this case then, I have a vertical asymptote, it's going to be x equals, and so then the vertical asymptote changes when we move it sideways. Well, remember we moved it right 3. So that means that our asymptote moved right 3 as well. So that means that my vertical asymptote is going to be at x equals 3. My horizontal asymptote, well, of course, that one now has to be y equals, right? And it's going to be y equals what in this case?
5.
Yep. It's been moved up 5, so it's going to be up at y equals 5. Notice on my graph, I start by drawing those in as dotted lines. So do so on your graph. Now, part of the reason why we draw those in is because now when going and making the graph, I don't need to worry about anything else. I'm really just making my graph starting from the intersection of the asymptotes here. That's my new origin, basically. And so my parent function, 1 over x, it starts over 1 and up 1. So that means this one is also going to start over 1 and up 1. I can go ahead and put my first point in there. And I know that because I know the parent function. And so knowing the parent function is essential in order to be able to continue through these. Right now, plotting the points from there, I'd expect at least 3 to 5 points in each of the quadrants that are formed by the asymptotes here. So, if I go over 2, how far up should I go? Well, it's like 1 over 2, right? 1 over 2 is a half. So that means I would go over 2 and up a half like that. Or if I went over 3, how far up would I go?
1/3.
1/3, because 1 over 3, or over 4 up a fourth, or over 5 up a fifth. You can plot any of those points, or all of them if you wish, and they give you a pretty good idea of what's going on over there. But we also want to include the points of what's going on up here. So if I go over only a half, how high up would I go?
2.
1 over a half, 1 divided by a half, yes, is 2. So I go over 1/2 and up 2. And you can even see that in the table that we made in our work yesterday. Or if I went over 1/3, I would go up 3, and so on and so on. And so that lets me get some of those points up there. Remember, you want to plot at least a couple of them. I'd say 3 to 5 points total up in this quadrant. And that'll give you enough to be pretty accurate. Now we want to go into the other quadrant, which is going to be the bottom left here. Well, first up, I'm going to go left 1 and down 1. I know I have that point to start with. But then from there, it's really following the same kind of pattern. So like over 2 and down a half. or over 1/2 and down 2. And I end up basically with that same kind of a shape, the same pattern as what I had in the positives, just now going negatives. That is left and down. And then, remember, you need 3 to 5 points in there so that you can be fairly accurate with your curve. Once you plotted those points, draw your curve through them. And then the one thing we haven't yet discussed on this is the domain and range. So the domain, well, first of all, is domain dealing with the x's or the y's again? It's the x's, yes. And so here my domain is going to be x cannot equal what?
3.
3, exactly. It's basically representing this asymptote right here. We're saying that x cannot actually equal that number. But notice that it equals everything else. That's why we're just saying it's all real numbers except for the 3. All right, so then the range, well, of course, that's got to be our y values, right? And in this case, y cannot equal,
5.
and again, I go to the asymptote, yeah. So y cannot equal 5. So now we're going to be tackling this equation. Y equals -2 over x. Now, in this case, again, I want to start by thinking about what the parent function is. But the parent function, because we have the x on the bottom of the fraction, it's still going to be y equals 1 over x. So it's actually the same parent function as what we saw in the last one. But the behaviors of these particular transformations, they're going to give us a little bit of a different feel in terms of kind of psychologically what it takes to be plotting some of these points. But again, it's still going to be based off of the same original function. All right, so the transformations. Let's start with the negative out front. When I put a negative out front, what does that do to my graph?
Reflect it.
Yep, it reflects it. Which way?
Across the x-axis.
Yep, it reflects it across the x-axis. That is, it flips it upside down. So what was up will be down, and what was down will now be up. Okay? And what about the 2? What's the 2 going to do for us?
Vertically stretch.
It is a stretch, specifically vertically. And so that tells me that not only will it be flipping upside down, but we're also going to be going higher and lower here. Now, those are our only 2 transformations in this one. There's no addition, there's no subtraction. That means there's no shifts up here in my transformations. Since there's no shifts, where will my asymptotes be?
0.
At 0, absolutely. And so since both asymptotes are at 0, I still want to make sure that I remember that that's where they are. So I go ahead and still draw in dotted lines. It can be tempting when it's on an axis to not draw them in. But if we don't, we might think that we just forgot to put it in. So I would still draw it in. All right, now that I've drawn my asymptotes, I need my first point. Now, to help visualize this, I'm going to start by just kind of seeing where would I normally have put it. And normally, without any of those transformations, my first point would go there, over 1 and up 1. But we got 2 different transformations here. The first one listed is to reflect it across the x-axis. So that now moves that first point down below the x-axis. I flipped it upside down. So up 1 became down 1. But then that's not the only thing. We're also applying a vertical stretch by a factor of 2. So instead of down 1, I'm now going to go down 2. Going down twice as far. And so then this is actually where my first point goes. Over 1 and down 2. This is the part that with these reciprocal function graphs tend to be the trickiest. So as soon as you got this down, they're going to get to be a lot simpler, and you're going to be able to handle the really tough ones as we go. All right, on to the next point then. So the next point, I would normally go like over 2 and up 1/2. Well, of course, we're going to go down now. But instead of going down 1/2, remember I need to go down twice as far. Well, what's 1/2 times 2? 1. So I go over 2 and down 1. All right, after that, I would normally go over 3 and up a third, or in this case, over 3 and down a third. Okay, but I still got to multiply by 2. What's 2 times a third? Well, 2 times 1/3, yes, would equal 2/3. So I'm going to go over 3 and down 2/3. And we can keep doing the same thing for the rest of them. So like over 4 and up a fourth becomes over 4 and down a half, because 2/4 reduces down to be a half. And so, again, you want to plot at least a couple of the points on that side there so that you can be fairly accurate as you draw it in. But again, I want to be able to draw in what's happening over here. So I'm still going to start with what would I normally do. And normally, I might go over a half and up 2. So normally I'm going there. Well, I'm going to flip it upside down. So that brings it down to over a half down 2. But I still got to double it because I still got that 2 up top. And so instead of over 1/2 and down 2, it's going to be over 1/2 and down 4. Absolutely. Yep. And then what about like a third? Because normally I think of going over a third. Well, normally over a third would be up 3. So in this case, it's going to be over 1/3 and down 2 times 3, yes, which is 6. And then from there, our over 1/4 up 4, well, that would be over 1/4 but down 8. Or if I wanted to go over 1/5, I normally go up 5. So over 1/5, that'd be down 10. So whatever I normally go up, that's what I'm multiplying by the 2 and flipping it upside down. Now, I've got enough points to be able to make my graph cleanly on that side, but now I need to plot the other. So now I go to the other side of my asymptotes. Normally, again, I always start with what I normally would do. Normally, I'd start by going left 1 and down 1. So normally I'd end up there. But again, I need to flip that across the x-axis. And so that's going to be actually left 1 up 1. That takes care of the negative, but then I still have to stretch it by the factor of 2. And so then I'm going to actually be left 1 and up 2. Notice the symmetry between that point here and this point down here. They both were over 1 and up or down 2. Just like normally they're both over 1 and up or down 1. We're just multiplying it by the 2. And then because of that symmetry, actually the way that we get all of these points out here is going to be the same that we get the rest of the points in the top left as well. So I can go ahead and plot those now. And then once you plotted at least 3 to 5 points in each quadrant, go ahead and draw your curve through those points, and you have your graph.